Welcome back to the SWAYAM NPTEL course on mechanical and electrical systems of mining machines. We are at lecture 20. So, this lecture is a tutorial on power transmission system. So, this lecture is a part of module 1, that is fundamentals of mechanical systems in mining machines. So, we will be covering 4 questions on power transmission system. So, what exactly is required to be calculated in power transmission system? So, there is a term called as tractive effort that we require to know while a vehicle is moving on a level surface or in an inclined surface. So, basically in mines, so there are higher gradients that the vehicle has to compensate. So, how does it compensate, or how much effort is given by the vehicle to climb up a gradient or come down a gradient? We will be understanding in details in this topic. Now, this effort that we are talking about is called as the tractive effort. What exactly is a tractive effort? When a vehicle is moving, we have understood that there is a resistance that is created by the road surface, which is imparted onto the wheels of the vehicle. Now, when a vehicle has to be stopped, we know that it should be equal and opposite to its mass of acceleration. So, when the vehicle is accelerating at certain speed, so when we have to apply the brakes, so it has to be equal and opposite to the acceleration of the vehicle. However, what is the effort that is given by the vehicle when it is climbing up a gradient or even moving on a level surface? Is it only the road friction, or is there any other frictions that are involved? So, this is defined by this tractive effort. So, in technical terms, if we try to explain what is tractive effort is a tangential pulling or hauling force exerted by a locomotive, vehicle or machinery at the wheel surface contact point to move a load. So, when the vehicle is moving, when the tire is moving, so how much effort it has to resist, or what are the resistance that are coming to the acceleration in order to make the vehicle move. So, that is defined by the tractive effort. Now, what exactly are these forces? So, it represents the total usable force available to overcome resistance, which is friction, gravity or inertia, and also the acceleration. So, in total, if mathematically we try to tell what is a tractive effort, it is the rolling resistance, which is given by Fr, plus the aerodynamic resistance, that is the air resistance while the vehicle is moving. So, that is given by Fa, and then there is a gradient resistance which is given by Fg. However, there is also a inertial resistance which it has to overcome, which is given by Fi. So, when we try to tell it with notation, our Fr is nothing but it is small fr mg, that is Fr is the rolling frictional coefficient, and then mg is the mass and g is the acceleration due to gravity. Here Fa is the aerodynamic force, where it is given by half rho CD a v square. Fg is given by mg sin theta, and Fi is given by delta ma. So, here the term delta is a mass factor. Now, the points that we need to know in the tractive effort is that the tractive effort is force at the wheels and it is not the engine force. So, this is a very important point. Then the second point is the aerodynamic resistance scales with v square, that is the velocity, and dominates at higher speed. The gradient resistance is independent of the speed, and the inertial resistance exists only during acceleration or deacceleration. So, now coming to Okay, before going to the question, so this slide tells about gives the explanation of all the notations that we have used in the earlier slides and where exactly it is used and what is its effect has also been shown herein with its units. Now, the first question that comes is for calculating the tractive effort at constant speed on leveled road. So, this question is as such: a passenger car has the following specification. The mass of the vehicle is 1500 kg, the rolling resistance coefficient is 0.015, the frontal area A is 2.2 square meter, the aerodynamic drag coefficient CD is 0.32, air density is 1.225 and vehicle speed is around 90 kilometers per hour, and the road is a leveled road, it is not an inclined road. So, what we have to find? We have to find the rolling resistance, the aerodynamic resistance and the tractive effort that is required. So, coming to the solution. So, first the vehicle speed is given. So, we have to convert it into the velocity. So, convert the velocity into meters per second. So, here V is equal to 90, we multiply it with 1000 divided by 3600, which is given by 25 meters per second. Then the first question that comes is the rolling resistance. So, how do we find the rolling resistance? It is given by Fr, which is, we know it is the rolling resistance coefficient multiplied with mass with acceleration due to gravity. So, here it is 0.015 multiplied with 1500 and multiplied with 9.81, which gives us the value of Fr as 220.7 Newton. Then the second question comes where we have to find the aerodynamic resistance. So, the aerodynamic resistance Fa is given by half rho CD A V square, which is given by 0.5 multiplied with the rho is given as 1.225 multiplied with CD as 0.32 multiplied with the frontal area, which is 2.2 multiplied with the velocity that is 25 square, which is given by 269.5 Newton. So, the total tractive force number 3, that is the total tractive effort that is required, effort TE is equal to Fr plus Fa, which is equal to 220.7 plus 269.5, which is equal to 490.2 Newton. Now, going to the next question. So, this is one answer, this is another answer and this is the first answer. Okay. So, now going to the second question where it tells that the vehicle mass is around 2000 kg, which is m, rolling resistance coefficient is equal to 0.02, that is Fr, the gradient is 1 in 20 and the speed is 60 kilometers per hour. Here your CD is 0.4 and your frontal area is 2.8 meter square. Air density here is given as 1.225 kg per meter cube. So, we have to find the total tractive effort. So, let us find the solution. Here the vehicle is moving up the gradient, which is 1 in 20. So, first we find the velocity in meters per second, which is equal to 60 multiplied with 1000 by 3600, which is equal to 16.67 meter per second. Now, when we find the rolling resistance Fr is Fr multiplied with mg, which is equal to 0.02 multiplied with 2000 multiplied with 9.81, which is equal to 392.4 Newton. Well, when we talk about gradient, so here our gradient is given as 1 by 20. So, here my sin theta is equal to 1 by 20. So, my Fg, that is the gradient resistance, is given by mg sin theta. In the previous question, so there was no gradient. So, therefore, this Fg was 0, and we have not considered the inertial resistance. So, that is why our tractive effort was the summation of rolling resistance plus aerodynamic forces. In this question, we have a gradient of 1 in 20. So, our solution includes the gradient resistance, which is 1 by 20, is given as 981 Newton. We also have the aerodynamic resistance Fa, which is equal to half rho CD AV square, which is equal to 0.5 into 1.225 into CD is given as 0.4 multiplied with 2.8 multiplied with 16.67 square, which is equal to 190.7 Newton. Now, my total tractive effort is Fr plus Fg plus Fa, which is equal to 392.4 plus 981 plus 190.7, which is equal to 1564.1 Newton. So, this is the total tractive effort that is required to maintain constant speed. Similarly, there is another question where while the vehicle is accelerating on a leveled road. So, how can we find the tractive effort that is required? So, coming to the solution. So, what is the question? The vehicle mass is 1200 kg, the rolling frictional rolling resistance coefficient is 0.015, which is Fr. Vehicle accelerates from 0 to 72 kilometers per hour in 10 seconds. Now, my CD is given as 0.3, my frontal area of the vehicle is 2 meter square, air density is 1.225 kg per meter square, which is rho. So, we have to find the tractive effort that is required at 72 kilometers per hour. So, the first thing that we find convert is we convert this speed into meters per second, that is in kilometers per hour multiplied with 1000 divided by 3600, which is equal to 20 meters per second. So, my acceleration now will be A will be 20 minus 0 by 10. So, 20 is the speed, final speed, my initial speed is 0 divided by 10, velocity by 10, it gives me 2 meters per second square. So, here I have the acceleration resistance, that is the inertial or the acceleration resistance. So, my acceleration resistance is, how do I find it? Fi is equal to ma. So, if there is a mass factor that is given, that is delta, then we also have to take in account here. However, it is not given in the question. So, that is why my inertial resistance is F is equal to ma, which is equal to 1200 multiplied with 2, which is 2400 Newton. The rolling resistance Fr is equal to Frmg, which is equal to 0.015 multiplied with 1200 multiplied with 9.81, which is equal to 176.6 Newton. Now, Fa, that is the aerodynamic force, is half rho CD A V square, which is equal to 0.5 into 1.225 into CD is 0.3 multiplied with 2 multiplied with 20 square, which is equal to 147 Newton. So, the total tractive effort TE is Fi plus Fr plus Fa. So, here we do not have Fg because this is 0. So, this gives me 2400 plus 176.6 plus 147, which is equal to 2723.6 Newton. So, this is the final answer. Now, there is another question where we will be seeing the effect of all combined resistance. Here the question is given as the vehicle mass is 2500 kg, the rolling frictional resistance is Fr is given as 0.018, the gradient is 1 in 25, which is equal to sin theta. The speed is 80 kilometers per hour, which we have to convert it into meters per second. Acceleration is given as 0.8 meters per second square. The CD, that is the aerodynamic coefficient, is given as 0.45. The frontal area is given as 3 meter square. The air density is given as 1.225. So, here we have to find the total tractive effort. So, we go ahead where we find the solution as V is equal to 80 into 1000 by 3600, which is equal to 22.22 meters per second. Then my rolling resistance is Frmg, which is equal to 0.018 into 2500 into 9.81, which is equal to 441.5 Newton. My gradient resistance is mg sin theta, which is equal to 2500 into 9.81 into 1 by 25, which is equal to 981 Newton. Now, Fa is equal to half rho CD A V square, which is equal to 0.5 into 1.225 into 0.45 into 3 multiplied with 22.22 square, which is equal to 408.7 Newton. Now, the last one is the inertial resistance Fi. My Fi is given as mass into acceleration. Here also the delta form is not given. So, it is 2500 into acceleration is 0.8, which is equal to 2000 Newton. So, my total tractive effort is 441.5 plus 981 plus 408.7 plus 2000, which is equal to 3831.2 Newton. So, this is my final answer. So, similarly, if such problems comes, you can be able to solve this way. So, these are the references that you need to follow for this part of the tutorial. Thank you so much.